Now the next one's the 2000 Form B in the third section. They give us the graph of f in this one. And it goes from -4 to 6. It tells us that you got tangent to the x-axis at x equals 3. And it's got that the second derivative is greater than 0. So it says, A, if f is differentiable, is f differentiable at x equals 0, use the definition of the derivative of one-sided limits to justify your answer. So remember back before you knew derivative rules, we would do the limit, and that would tell us our derivative. The shortcut way is looking at the slopes because, you know, that is derivative. So if you go to 0, if you're coming from the left, you've got a positive slope, and if you're coming from the right, you've got a negative slope. So they obviously are not going to match, so it is not differentiable at 0. For part B, for how many values of A does the average rate of change a to the 6 equal to 0? Give a reason for your answer. Okay, so you know average rate of change is f of 6 minus f of A over 6 minus A. And we want to know where it would equal 0, the value of A. Well, we know f of 6 is 1. So minus f of A, then that means f of 6 would have to equal f of A for the numerator to be 0. And there are two values, x equal 1 and x equal approximately negative 1.5 is where it would equal 1. So part C says, is there a value of A which the mean value theorem applied to the interval A to 6 guarantees a value at which the derivative at that point C would equal 1/3, justify your answer. So we want to know f of 6 minus f of A, 6 minus A equal 1/3. So you got to just kind of, I just kind of played around with some figures between there that would make it equal, because you know 6 minus 3 is going to be 3. You know this is 1. So what would this have to do to equal 3rd? It would have to be 0. And where is f of A equal to 0? It's f of 3. So part D, the function is defined by g of x equals 0 to the x of f of t on the interval from -4 to 6. On what intervals is the graph G concave up? So g of x is going to be concave up where g prime of x is increasing because of that relationship. So if you got g of x equals 0x f of t, remember when you take the derivative, if you take the derivative of an integral, it's just f of x. So we're looking on this graph of f of where it's increasing, and it's increasing from -4 to 0 and 3 to 6. So that's where G would be concave up. This is another 2009 Form B, and they give you a graph of f prime, and they say f of 1 equal 2. And you know you got a horizontal tangent at x equal 2, and it says g of x is equal to e raised to the f of x. And remember, this is the graph of f prime. So it says write an equation for the line tangent to the graph of g at x equal 1. So remember, we need an ordered pair and a slope. So g of 1 is going to equal e of f of 1. Well, they told us f of 1 was 2, so we know that's e squared. G prime of x, remember when you take the derivative of an e function, it's the e function times the derivative of whatever it's raised to. So it's going to be e f of x times f prime of x. So G of 1, so E of f of 1 again is E squared, and f prime of 1 is negative 4. So our slope is negative 4E squared. So when we put that in y equal mx plus b, we got E squared equal negative 4E squared times 1 plus b. And if you bring that over, I didn't combine it there, but technically it's going to be 5E squared is going to be your b. So if you put it back in, y equal negative 4E squared x plus 5E squared. So that's going to be your tangent line. Now part B says from negative 1.2 to 3.2, find all the values where g has a local maximum, justify your answer. So remember, g of x was e to the f of x. So g prime of x is e to the f of x times f prime x. Well, by definition, e of the e function, e to the f of x, is always greater than 0. So we just need to see where f prime of x changes from positive to negative, because that would be a max. And it does it at x equal negative 1. So that's going to be our local max. Part C says the second derivative is e, and it gives you this long formula. You can look at it on your paper. Is g prime of negative 1 positive, negative, or 0? Justify your answer. So you're going to come down here and write your formula out, and you're going to plug it in. So it'd be e f of 1, f prime of negative 1 squared plus f double prime of negative 1. We know e of f of 1 is e squared. F prime of negative 1 is 0. And we don't know what the exact second derivative of negative 1 is, but if you look up at negative 1, you do know it's negative, because that slope is negative. So I'm just going to put a negative sign there. So that ends up being negative e squared, so the whole thing is negative. And part D says find the average rate of change of g prime over the interval 1 to 3. So we're going to do g prime 3 minus g prime 1 over 3 minus 1. So g prime 3 is e f of 3, f prime of 3 minus e f of 1, f prime of 1. You don't know what e f prime of 3 is equal to. E f of 3 is equal to, but you know f prime of 3 is 0, so that whole thing goes away. And then you got minus e squared divided by 2, and that's going to be negative 4, because 1 is negative 4, so you end up getting positive 2e squared. So let's look at another example in your notebook to the 2009 in the third section. So it gives us the graph of f prime, and it shows us that f prime is a piecewise g of x, and then we have a function rule for the second part. And it says that has x-intercepts at x equal negative 2 and x equal 3, ln of 5/3. And the graph starts at f of 0 equal 5. And this is on a non-calculator part. So part A says find all values of x at which the graph of f has a point of inflection. Again, it's going to be x equal negative 2 because f prime changes from decreasing to increasing, and x equals 0 because f prime changes from increasing to decreasing. Part B, find f of negative 4 and f of 4. So remember, when we don't have a function rule, we use geometric shapes in our starting point. So we're going to have f of 0, 0 to negative 4. Well, because our integrals are mixed up, we have to change and put a subtraction sign and go from negative 4 to 0. Now, when you go negative 4 to 0, you're really talking about this little side part in here. So what you want to do is do the rectangle minus out the semicircle, and you'll have those two little sections. So I've got 5 minus rectangle minus the semicircle. That's 4 times 2 minus 1/2 pi 2 squared. If you put all that together, you get negative 3 plus 2 pi. Now f of 4, you're going to do f of 0, 0 to 4. And your 0 to 4, you have a function rule. So you've got 5e to the negative x3 minus 3. So we're going to split that up. I pulled the 5 out, got e to the negative x3 minus, and then I've got 3. I've got to do u substitution here. U will be negative 1/3 x, so du will be negative 1/3. So that means I have to put a negative 3 on the outside. So I've got 5 plus 5 times negative 3. And then it'll be e to the negative x3, 40, minus 3x, 40. And if you do all the math there, you'll get 8 minus 15e to the negative 4/3. Now part C, it says find the value at which f has an absolute minimum, justify your answer. So I need to try my endpoints, and my endpoints are f of negative 4, f of 4, and then where it changes, I'm doing an absolute maximum, so it's going to be from positive to negative, so that's 3 ln of 5/3. So we already know f of negative 4 and f of 4, we got it. I tried doing it algebraically, but it doesn't work. And remember, this is a non-calculator part, so you can't even use your calculator. So you got to go back and conceptually think about it. So if you look at the graph, the derivative is positive all the way to the point that we're talking about, 3 ln of 5/3. So that means if you're at negative 3 plus 2 pi, you're increasing all the way to that point. And then the derivative is negative, so that means you're decreasing down to your next endpoint. So that means that that has to be the absolute max. So 3 ln of 5/3 would be your absolute max.